Hi everyone. I just want to throw together another example. So I'm just going to pause here for a second, let you read that question quickly. So here's what's going on. This is similar to the airplane one where the airplane is heading north and the wind is blowing on it, making it head off northwest. Same idea. We have a truck that's traveling just a little bit off of north, and then a wind blows upon it when it crosses like a bridge or something. And then this is the resultant velocity. So if we were doing it graphically, it'd be fairly easy, and I'm just going to sketch it out quickly, just to give me an idea what's going on so if I know if I'm in the right direction. So this is the velocity of the truck itself, somewhere around there. And then, after the wind blows on it, the velocity of the truck is something like this. So I know that the wind must be blowing somewhere around this way. You could do it all graphically and solve it very quickly if you have a protractor and a ruler and you get really quite close. Or you can do it mathematically. So you do it mathematically, what we have is the resultant velocity. So this is the velocity after everything. This would be the velocity of the wind blowing on the truck, and this is the velocity of the truck. So it's very similar to that question. So the first velocity, call it the truck, and it is 108 kilometers per hour, and I can leave it in kilometers per hour because everything's in kilometers per hour. And the angle is 10 degrees off of north, so that would be 90, and then 10 back towards the east, so that would be 80 degrees. We don't know the velocity of the wind, and we know the velocity, I'm going to call it net, of the resultant, is 112.5 kilometers per hour at we got north 19 degrees to the east, so north and then 19 back this way would give me 71 degrees. So I'm just going to draw in my table. So make your table, draw the lines on it. It makes it a lot easier to follow for everybody. I'm just going to crunch the numbers. Alright, so to save time, I went and crunched these numbers. So of course, 108 times the sine of 80, 108 times cos of 80, 112.5 times the sine times the cos. Those are the values I have. And I'm missing the value, so I want to put this sort of line in my table here. I'm missing these two values, so of course I have to work backwards. And don't just put the number in there. You got to show something so someone can look at it. Right, if I just threw that number in there, you wouldn't be sure where it came from either if I showed you without doing the work. So you remember V net in the y direction, so the y first, but you can do x first, is the velocity of the truck in the y direction minus the velocity of the wind in the y direction. And then we do the same thing in the x direction. Velocity net in the x direction equals velocity of the truck in the x minus the velocity of the wind in the x. So I've gone ahead and crunched the numbers in here. So I did the subtraction and I found the velocity in the y direction is 0.01 kilometers per hour. So it's basically probably just a rounding thing here with this degree, but we're going to use that just to kind of discuss this question. And I've done the x value. So now that I have these two values, right, remember to finish off the question, if it asks you in the I and J hat, the answer would be velocity of the wind equals 17.88 kilometers per hour I hat plus 0.01 kilometers per hour J hat. So that would be the end answer if we were just stopping there. If you wanted to finish it up and find out what the actual direction was, then you got to draw your x and y. Remember, draw the x first. So the x value is this, 17.88. And then from that one, not from the starting point, but from here, we draw the y one, which was 0.01 kilometers per hour. You would do Pythagoras. R squared equals the x squared value plus the y squared value. So in this case, not the r squared, sorry. It's just the r. I already did the squared root part. R is equal to 17.88 squared plus 0.01 squared. Take square root of that. And r is still going to equal 17.88. And looking at that, since there's basically no y component, you would still do the angle as tan of theta is equal to y over x. But theta is essentially 0 degrees. So the wind is, and we work so often in meters per second, that we always think our answer should be meters per second. But remember, we left this in kilometers per hour, so the wind is blowing 17.88 kilometers per hour east. So that's how you do those questions. If you had a different y value, of course you get a different angle here, but since they're so close, that's essentially a 0, then the angle would be 0. So the inverse tan of 0 is 0. So that's how you do that question. If you have it as a multiple choice, it's pretty straightforward. Draw the sketch, right? If the question had been, is the wind blowing northwest, east, or south? Draw the first vector, draw your resultant, go from the first one to where the resultant ends, and that's going to tell you what angle you're at. Okay, hopefully that helped. If you don't need to do it, you don't have to watch this. Great, thanks.